In Chapter 3, we're going to learn how to solve quadratic equations. And remember, a quadratic equation is just any equation that has a highest power of x squared. So that's what we were graphing in Chapter 2. So one of the ways we can solve a quadratic equation is by graphing. And that's what we're going to focus on today. So here you can see the steps for solving by graphing. We've got find the x-intercepts of the quadratic function. So basically where that graph crosses the x-axis, those are called our roots or solutions. We can also solve quadratics by taking square roots. We're going to learn about that later this week. And then we can solve by factoring, which we will learn about the following week. So you'll see the instructions for using square roots and factoring in future sets of notes. Okay, so when we solve quadratics by graphing, we start by graphing the quadratic. So that's going to look different depending on what type of quadratic we have. So if we have the standard form, remember, that's where we find the x-coordinate of the vertex first using that opposite of b over 2a formula. If you have vertex form, that's where you find the vertex with hk, and then you would make a t-chart. And if you have factored form, squeeze that a in there, usually it's written as x minus p at x minus q. That's where you have your x-intercepts at p and q. And those x-intercepts are what we want to find in order to solve our quadratic. So we want to find those quadratic or x-intercepts. So basically, where does the graph cross the x-axis? So the examples that we're going to see today are standard form, which is probably one of the more difficult ways to solve quadratics by factoring or by graphing. Because if you have this intercept form, you have those solutions right here. They give you your x-intercepts. So that one's probably the easiest form. Okay, so here is an example. We've got x squared minus x minus 6 equals 0. So this is that standard form. A is equal to 1 because it's a 1x squared. B is equal to negative 1. And then C is equal to negative 6. So x coordinate of the vertex is opposite of b over 2a. So that's going to be a positive 1 over 2 times a, which is 1. So the x coordinate of the vertex is 1/2. Y coordinate of the vertex, we plug in that 1/2. So we've got 1/2 squared minus 1/2 minus 6. And we could type this into our calculator, or we can square that fraction. That's a 1/4 minus 1/2 minus 6. And then we need to go ahead and get common denominators. So here we'd have to do a 2 over 2. This is 6 over 1. So we need a 4 over 4. So this would really be 1/4 minus 2/4 minus 24/4. So here, 1/4 minus 2/4, that's going to be a negative 1/4. Negative 1/4 minus 24/4 is negative 25/4. And so then at this point, we probably would want to convert that to a decimal or at least a mixed number so that we can easily figure out where that's going to go on the graph. So if I do that, I get negative 6 1/4 or negative 6.25. So I can go ahead and graph that. I'm at 1/2 and then negative 6.25. And then in order to find another value, I want to make my t-chart. So here, I'm going to put that vertex in the middle, 1/2, negative 6.25. And then I probably don't want to pick 0 because that's going to be pretty close to that point. Maybe I go 1.5 to the left. So I'm going to pick x equals negative 1. And then I go 1.5 to the right, and I'm going to use x equals 2. Remember, I only have to plug one of those values in for x because the graph is symmetric. I'm going to plug in the 2 to keep it positive. So when I do that, I have 2 squared minus 2 minus 6. So that's going to be 4 minus 2 minus 6. So 4 minus 2 is 2. 2 minus 6 is negative 4. So at negative 1, I have a point at negative 4. And at positive 2, I have a point at negative 4. And then I would go ahead and connect my graph. And I'm looking for where that graph crosses the x-axis. My graph crosses the x-axis at 3 and -2. So that tells me the solutions to this equation are x equals -2 and x equals +3. Again, because those are the x-intercepts here. Here's another example. This one's a little trickier because it's not in standard form. We want x squared x followed by constant. So we're going to move this 4x over to the left-hand side. This will be -2x squared minus 4x minus 2 equals 0. So I have a equals -2, b equals -4, c equals -2. X coordinate for the vertex is opposite of b over 2a. So that's going to be a +4 over 2 times a, which is -2. So it's 4 over -4 or -1. I want to find the y coordinate of my vertex. So I'm going to plug this into my original here. I've got -2 times -1 squared minus 4 times -1 minus 2. So this here is going to be -2 times 1, which is -2. -4 times -1, that's going to be a +4, and then -2. So when I go ahead and add these together, -2 plus 4 is 2. 2 minus 2 is 0. So I can go ahead and graph my vertex at -1, 0. And looking at that, my graph crosses the x-axis there. So I know that one of my solutions is going to be x equals -1. I want to see what else my graph does. So I'm going to make a t-chart. I'm going to put that vertex in the middle. And again, I'm just going to pick a value above and below my vertex. Maybe I pick x equals 0 and x equals -2. So if I plug in x equals 0, or if I remembered from the last section that this is my y-intercept, I have a point here, and then I can reflect it over to here. When I plug in that 0, if you wanted to see that, this is just 0 minus 2, which is that -2. So we can connect, and we can see here that this quadratic only touches the x-axis at one point. So here, this quadratic has only one solution. And something that we'll talk about as we get into higher order polynomials is that your highest exponent tells you the maximum number of solutions you can potentially have. So a quadratic can have up to 2 solutions, but it can have fewer, like this one only has 1. We can see in the next section some quadratics that are going to have no real solutions, and we'll see how to deal with those, like I said, in section 3.2. So there's no homework assignment for tonight. We just wanted to kind of tie everything together with graphing and then how graphing helps us potentially solve quadratic equations.